Okay, now we continue with example 5, implicit differentiation. Find dy over dx if sinh cube 2x plus x inverse tangent y equals to e to y. This is implicit differentiation because we cannot write y as a subject. Okay. This is example 4 in page 22, chapter 2 in your handout. Okay, now we look at the complete solution. We are given sinh cube 2x plus x times inverse tangent y equals to e to y. So now we define one by one. We define sinh cube 2x as a plus define x inverse tangent y as b equals to, we define e to y as c. Then we differentiate one by one. So we have a prime plus b prime equals to c prime. And we name as equation 1. Then we can show the derivative of a, b, and c one by one. Okay. So our a is sinh cube 2x. And we can write into the form of bracket sinh 2x cube to easy differentiate. Okay. And every time when we have bracket and the power of n, we can differentiate using generalized power rule. Okay, we differentiate a, so the symbol is a prime. So to differentiate sinh 2x cube, we can use generalized power rule. We need to bring power to the front. Okay, so we have 3 here from the power. And then we copy in bracket, and at the same time the power will become 2 y2 because the formula is power minus 1, which is 3 minus 1, so equals to 2. And then we differentiate in bracket. Okay, in bracket actually is composite function because we have sinh 2x, we can write the first circle and attach to another circle. Okay, and inside sinh x we have, inside sinh 2x we have, inside sinh we have 2x. Okay, so we can write the second circle attached to another circle. Okay, to differentiate sinh 2x, we can refer from derivative of sinh single x, which is equals to cos single x. So when we differentiate sinh 2x, the answer should be cos 2x. And before that, in between must multiplication operation. Okay. And then we differentiate 2x. So the answer should be 2. Okay, after that, okay, we differentiate here. So we get here from this formula, we differentiate 2x, we have 2 from this formula. Okay, and after that we simplify, we can multiply 2 by 3, so we have 6. We can bring 2 here, so we have sinh squared 2x cos 2x. Okay, now we differentiate b. Our b is x inverse tangent y. This is actually multiplication operation. So we need to use product rule to differentiate. When we use product rule, we need to identify u, v, find u prime, and find v prime. Okay, our u is x, and then we differentiate x, the answer is 1. Our v is inverse tangent y, and when we differentiate, we have v prime equals to 1 over 1 plus y squared times dy over dx. How to differentiate inverse tangent y? Okay, we can refer from derivative of inverse tangent x, which is equals to 1 over 1 plus x squared. So means that when we differentiate inverse tangent y, the answer should be 1 over 1 plus y squared. We just replace x here. Okay, for inverse tangent y. So this is x. And then we need to differentiate y. So the answer is dy over dx. Okay. And then using product rule, we write the formula, we differentiate b, the symbol is b prime, and then we write the formula for product rule, which is vu prime plus uv prime. And then we substitute. We substitute v, our v is inverse tangent y, we substitute u prime is 1. And then plus, we substitute u, our u is x. And then we substitute v prime, our v prime is 1 over 1 plus y squared dy over dx. Okay. Then we just simplify. So, inverse tangent y times 1. So, we still have inverse tangent 1. And then plus x we can put here in numerator. So, we have x over 1 plus y squared dy over dx. This is for b prime. And then we need to find c prime. So, our c is e to y. So, to differentiate e to y, we differentiate c, the symbol is c prime. And then we differentiate e to y, we have e to y times 2 dy over dx. Okay. And then we simplify the answer. So, we can put constant in front. Okay. Okay, before that, how to differentiate e to y? From formula derivative of ex. The answer is ex also. So, when we differentiate e to y, the answer also e to y. But after that, we need to differentiate to y. So, when we differentiate to y, we still put 2 here and we differentiate y, which is dy over dx. Okay. Okay, next we substitute a prime, b prime and c prime into equation 1. Okay, so we have equation 1, a prime plus b prime equals to c prime. Okay, we recall back what is equation 1. Okay, then we substitute a prime. A prime is 6 sin squared 2x cos 2x plus we substitute b prime. Our b prime is inverse tangent y plus x over 1 plus y squared dy over dx equals to, we substitute c prime, which is equals to 2e 2y dy over dx. Okay, and then we have two terms containing dy over dx. So what should we do is separating the terms containing dy over dx and the term not containing dy over dx. Okay. Let's say we bring the term containing dy over dx to right hand side. Okay. So, from right hand side, the original equation, we have 2e 2y dy over dx. This term also has dy over dx. So, this is positive sign. So, we move to right hand side. So, we have minus x over 1 plus y squared dy over dx. These two terms doesn't have dy over dx. So, means we leave to left hand side. So, for left hand side, we have term not containing dy over dx. And for right hand side, we have term containing dy over dx. Okay. And then, we factorize dy over dx. Okay. We move out dy over dx. So, in bracket, we have 2e 2y minus x over 1 plus y squared. For left hand side, still same. And after that, we write dy over dx as a subject. This is multiplication operation. So, when we write dy over dx as a subject, we need to move the operation, the multiplication operation to left hand side. So, now we have dy over dx equals to 6 sin squared 2x cos 2x plus inverse tangent y over because from multiplication operation. So, when we move to the other side, so we have division operation. So, over 2e 2y minus x over 1 plus y squared. To be continued, integration of hyperbolic functions. So, stay tuned. Bye. Assalamualaikum.